This is Pluto. At least, that's what we used to call it. For most of our lives, Pluto was simple, the ninth planet, the small one at the edge. We memorized it in school. My very educated mother just served us 9 pizzas and moved on without giving it much thought. Pluto was distant, quiet, frozen. And then, one day, without warning, Pluto was gone. Not destroyed, not lost, just reclassified. In 2006, scientists gathered, voted, and decided Pluto didn't meet their new definition of a planet anymore. Overnight, it was stripped of its title and demoted to a dwarf planet. No parade, no apology, just a quiet update in the textbooks. But here's the thing. Space doesn't care about our definitions. Pluto didn't suddenly change in 2006. Its mountains didn't collapse. Whatever Pluto was doing out there in the darkness, it just kept doing it, unbothered by meetings or votes from a planet billions of kilometers away. And that's where this story gets interesting, because the same year Pluto was demoted, a spacecraft was already racing toward it.
NASA scientists are receiving new images from a piano-sized spacecraft that flew past the dwarf planet. It is the result of $700 million and 3 billion miles of travel.
If Pluto truly didn't matter, why go to all that trouble? The truth is, Pluto's demotion wasn't about it being boring. It was about Pluto being inconvenient. To understand that, rewind to the early 1900s. Back then, astronomers noticed something odd. The orbits of Uranus and Neptune didn't behave quite right. Tiny deviations hinted that something unseen might be tugging on them from beyond. They called it Planet X. When Clyde Tombaugh discovered Pluto in 1930, it seemed to fit. It orbited the Sun, it moved like a planet. From Earth, it shone brighter than anything else out there. For decades, nobody questioned it. But as telescopes improved, the picture changed. Pluto wasn't alone. The region beyond Neptune was crowded, a vast disk of icy debris filled with countless frozen objects. Pluto wasn't a lone outpost. It was just the brightest object in a massive cosmic swarm. That realization forced a reckoning. If Pluto was a planet, so were many of its neighbors. And if all of them counted, the solar system would suddenly have dozens, maybe hundreds of planets. So, in 2006, the rules changed. A planet had to orbit the Sun, be round from its own gravity, and dominate its orbital neighborhood, clearing out similar-sized objects. Pluto failed that last test. Case closed. Except, Pluto's orbit is strange, elongated, steeply tilted, sometimes closer to the Sun than Neptune, sometimes far beyond. It doesn't follow the rules, it never has, and that raises an uncomfortable question. If Pluto doesn't fit our categories, is that a failure of Pluto or the categories? Definitions aren't discovered, they're invented. They're tools we use to organize reality, not reality itself. Pluto was the thing that didn't fit. But instead of abandoning it, scientists leaned in. Because objects that break the rules tend to be the most interesting. And quietly, while everyone debated labels, a spacecraft was already racing away from Earth at record speed. Not to prove Pluto wrong, but to see what it actually was. Because whether we called it a planet or not, Pluto was still out there, still ancient, still holding secrets from the earliest days of the solar system. And soon, for the first time ever, we were going to look it in the face. But first, we had to chase it across billions of kilometers of empty space, with one shot to get it right. If we were going to understand Pluto, there was only one way. We had to go there. And that immediately created a problem. Pluto is absurdly far. Even at light speed, signals take over 5 hours to reach it. With normal spacecraft speeds, the journey could take decades. Too long. So if this mission was happening, it had to be fast. New Horizons was built for speed. Small, stripped down, packed with cameras and sensors. No backup plans, no second chances. In January 2006, the same year Pluto was demoted, it launched on one of the most powerful rockets available. Within 9 hours, it blasted past the moon. Not days, hours. The chase had begun. For the first year, New Horizons cruised through familiar space, heading toward Jupiter. This wasn't sightseeing. Jupiter was a tool. By flying past at precisely the right angle, the spacecraft could steal gravitational momentum and boost its speed, shaving years off the journey. In February 2007, it worked perfectly. New Horizons slung past Jupiter, tested its cameras on the giant planet's storms and moons, then accelerated into deep space. And then, silence. For nearly a decade, the probe drifted outward through darkness. It slept most of the time, waking occasionally for health checks. Year after year passed. Back on Earth, people forgot about Pluto. But New Horizons kept moving, closing the distance, kilometer by kilometer. Then, in early 2015, the cameras turned toward their target. At first, Pluto was just a point of light, a single pixel. But day by day, that dot grew, brighter, larger. A second dot appeared, Charon, its moon. After 9 years, the chase was paying off. But now, the pressure was on. New Horizons wasn't going to orbit Pluto, it was going to scream past at 50,000 kilometers per hour, collecting data in a window measured in hours. Every command had to be pre-programmed, every observation scheduled. When closest approach happened, the spacecraft would be too busy to listen for new instructions. Humanity had one shot. As Pluto grew from a dot into a disk, something unexpected appeared. Variations in brightness, patches of light and dark, shapes that didn't look random. This wasn't the featureless ice ball everyone imagined. Then came the final approach. In July 2015, New Horizons flew past exactly as planned. When the moment happened, nobody on Earth knew in real time. Just silence as the spacecraft executed alone in the dark. Hours later, a signal arrived. New Horizons had survived.
We've seen images of Pluto from Hubble, from ground-based telescopes, but this is the first time we're ever going to see anything on the surface.
The data was secure. The images were coming. But as those first high-resolution pictures started downloading, one thing became instantly clear. If Pluto was truly insignificant, why did it look so alive? When the first images arrived, there was a pause. Not because the data was missing, but because nobody was ready for what they were seeing. Pluto wasn't supposed to look like this. Instead of dull gray, Pluto exploded with color. Deep reds, pale blues, creamy whites, burnt oranges. It was textured, layered, complex. And one feature dominated everything. A massive, bright, heart-shaped region carved into the surface, perfectly visible, impossible to miss. When I first saw that image, I got chills. After all the debates about whether Pluto mattered, there it was, wearing its heart on its surface. Scientists named it Tombog Regio, but what mattered more was what it represented. The left side of the heart was smooth, flat, vast, a frozen plain the size of Texas called Sputnik Planitia. And it had no impact craters. That's huge. In space, craters are fingerprints of time. The older a surface, the more scars it collects. But Sputnik Planitia looked young, which meant Pluto's surface was being renewed recently. Somehow, on a world 6 billion kilometers from the sun at minus 230 degrees Celsius, geology was still happening. But this ice wasn't water. At these temperatures, water ice behaves like solid rock. It doesn't flow. This was nitrogen ice, frozen atmosphere, soft enough to behave like slush, forming massive glaciers that slowly churned across the surface in convection currents. And convection requires heat. Heat on Pluto. Small worlds cool quickly and become dormant. Pluto should have been frozen solid billions of years ago. Yet here it was, moving. Around the heart's edges, towering mountains rose, some as tall as the Rockies, made of water ice so hard it behaves like granite. Massive slabs thrust upward, fractured, tilted. This wasn't erosion, this was tectonics. Beyond the bright heart, Pluto darkened. A vast reddish region stretched across one hemisphere, stained like dried blood, Cthulhu macula. The color came from chemistry. High in Pluto's thin atmosphere, sunlight creates complex organic molecules called tholins. They fall like microscopic snow, coating the surface in deep reds over millions of years. Pluto wasn't just geologically active, it was chemically alive. The atmosphere itself was complex, layers of distinct hazes extending hundreds of kilometers into space, an atmosphere that expands and collapses with Pluto's 248-year orbit, breathing across centuries. Then came the most baffling discovery. Pluto had volcanoes. Cryovolcanoes. Ice volcanoes erupting slushy mixtures of water, nitrogen, and ammonia. One, Right Mons, rose 5 kilometers high and stretched 150 kilometers wide, nearly crater-free, young. Something inside Pluto was still pushing material up, but where was the heat coming from? Pluto doesn't orbit a giant planet. It doesn't get tidal heating like Jupiter's moons. There was no obvious energy source. And yet, evidence pointed to something incredible. Beneath Pluto's crust, there appeared to be a subsurface ocean, liquid water, insulated by ice, kept warm by leftover heat and radioactive decay. A liquid ocean on Pluto. The implications were staggering. Liquid water, the key ingredient for life as we know it, hidden beneath the surface of a world we'd written off as dead. And Pluto's moon, Charon, also surprising. Vast canyons, deep fractures, signs of ancient activity. The two bodies are locked in an intimate dance, circling a point between them. Some scientists think they formed from a violent collision billions of years ago, an impact that injected energy still echoing inside Pluto today. Pluto wasn't an accident. It was a survivor. As images kept arriving, one truth became unavoidable. Pluto didn't fit our definitions because our definitions were too small. We'd assumed complexity faded with distance from the sun, that only large planets could be dynamic. Pluto proved us spectacularly wrong. This tiny world had glaciers, mountains, weather, chemistry, and possibly oceans. It had a violent past and an active present. Pluto wasn't quiet. It had just been whispering from too far away to hear. But here's what honestly breaks my heart. New Horizons wasn't slowing down. It wasn't staying. The closest images were captured in just a few hours. Pluto revealed its secrets in a brief encounter, then slipped back into darkness. Which raises the most unsettling question. If Pluto could be this complex, what else is hiding out there? What do you think? Should Pluto be called a planet again? Drop your thoughts below. By the time the last images downloaded, New Horizons was already millions of kilometers past Pluto. No victory lap, no second look. Pluto faded back into a point of light. And something strange happened. Pluto stopped being a debate and became a memory. For years, the conversation had been about labels, planet or not, right or wrong. But after seeing it up close, those questions felt small. Because what New Horizons revealed wasn't a technicality, it was a world with real landscapes shaped by billions of years of history. And here's the uncomfortable truth. Pluto didn't change. We did. We changed the definition, we changed the classification, but Pluto remained exactly what it always was, complex and mysterious. The demotion wasn't a discovery, it was a decision, and decisions can be revised. What Pluto exposed wasn't a flaw in itself, but a limitation in how we understand the universe. We love neat categories, clean borders, stable rules, but the cosmos has never cared about that. Pluto is a product of cosmic chaos, formed in the wild outer regions where nothing went according to plan. And maybe that's exactly why it matters. Because Pluto sits at the edge of something much larger. Beyond it lies the Kuiper Belt, hundreds of thousands of icy worlds we're only beginning to study. Pluto isn't an exception, it's a representative. And if Pluto is this active, this complex, what about the others? New Horizons gave us a glimpse, but only a glimpse. The encounter lasted hours. Full data transmission took 16 months. Scientific interpretation will take decades. And here's the hard part. NASA has other priorities. Mars, Europa, missions closer to home. There's no New Horizons 2, no return trip planned. The images we have might be all we get in our lifetime. And here's the irony I love. The mission that redeemed Pluto now does exactly what Pluto does. New Horizons continues through the Kuiper Belt, exploring dismissed regions of space, quietly, without fanfare, just like Pluto. If Pluto taught us anything, it's that ignoring the edges is a mistake. The edges preserve history. They show alternate outcomes, worlds that became something we hadn't imagined. Pluto isn't the end of the solar system. It's the beginning of a different chapter, one where worlds exist on a spectrum shaped by circumstances rather than rigid categories. And maybe that's Pluto's real legacy. Not that it lost status, but that it changed ours. It forced us to admit we don't have the universe figured out, that our definitions are temporary tools, not eternal truths. Right now, Pluto continues its long journey. Nitrogen freezes and thaws, glaciers creep, mountains stand in silence. And none of that depends on what we call it. Pluto exists on its own terms. It always has. And that might be the most planetary thing of all. Here's my final question. Should Pluto be reclassified as a planet, or does the whole debate miss the point? And what other dismissed things in science deserve a second look? Let me know in the comments. I read every one.